So today we'll be solving this problem from CSES Raab Game 1. This is a introductory problem, and the problem statement here says that we'll be given the input with tests. This is the first input, will be number of tests that will be given. Okay, so and the remaining inputs will be in the form of n, a, and b. N will tell this that will be given a number from 1 to n, and A is given that there are two players A and B, and these are the winnings of each of the player, and the criteria to win is like the value of an element in the array of A is greater than the strictly greater than the value in B. So in that case, A will win, and the vice versa is also true. To For the B to win, its value has to be greater than the value of A. And the range of the value for each of the players there they can take is 1 to n, 1 between 1 and n. Okay, so basically the problem statements are a bit different because both player A and B uses this plays a card game where each card has a numbers written on its face, and the numbers lies between 1 and n, and whenever uh, and at a time, one by one, each player plays card on the table, and whenever the card has a higher digit engraved on it, that player wins basically. So here we can see in the first test case we have the number from 1 to 4, and it is given that player A wins at least exactly one time, and player B exactly wins twice. So tell us how, if it is possible to uh, create a sort of like combinations of these four cards such that this condition satisfies that A wins one time, B wins two times. And if it is possible, then we need to print yes, and also the how it is possible. So that's what this error we need to print out over here. Similarly, if it is not possible, then we need to print no, right? So let's see on the first test case how it is possible. So in the first test case, we see that there are four cards. So player A starts, uh, uh, player A and player B unfold their first card. We can see that player A over here, player A has 1, player 2 has 2. So it means that player B has won one time. Then next, player A unfolds a card with number 4, and this one has 1. So in this case, player A wins. So 1 and 1 equals. Next, 3 and 3. So when there is a tie, it means that the score is 0 for both of them. Okay. And in the next term, player A throws a card with 2, and player B throws card with 4. So in this case, we can see that player B has won twice. This one first and the fourth time. Okay. And player A has won only one time, this second one. So this is a valid case. Okay. So that's why it is printed yes, and then all the possible options. Similarly, in the second test case, it is given that the numbers can lie from 1 to 2, and the player A wins 0 times, and the player B wins 1 time. So in this case, it is not possible. Why it is not possible? We'll see that. And in the third example, we can see that player A wins 0 time and player B wins 0 time, and the number can lie from 1 to 3. So this is if this is always possible. Okay, whenever A is 0 and B is 0, it is always possible because uh, it is always possible to write numbers. It is always possible to take throw cards in a way such that all the cards lie between 1 and n, right? So they all of them will throw in a ascending order. So this will result in 0-0 because no player will win. There will be a tie. And in the next case, the number lies between 1 to 2, and both player wins 1 and 1 time. So this case is also a valid one because at one time only player B wins, then the second time player A wins. Right? Now let's talk about the edge cases over here. So in the second test case, we see that it says that it is not possible, and we'll see why. Right? Because let's suppose here it is saying that here let's say so we player A is given one card with 1 and 2, and player B is given card 1 and 2. Now player A says that I don't want to win anytime. Okay, it means that it is forcing us to always have a tie. Okay, so it must have a tie. Either it is 1 to 2 or maybe 2 or 1, any possibility, right? So if this is the case, then the player B should always also have 1 to 2 or 2 or 1. Only then this will be a tie, right? So that's what it says. According to Ace, we need to make a tie. But in case B is saying that I want to win at least one time over here, right? And for the B to win, we have to make it in a way that at least one of the card has a less number, right? And we can see that to make the second case possible for the B, we have to alter the A's use case, and A is forcing us to always have the equal values. So yeah, so it is always the case that whenever any of the number is 0 and the another is non-zero, means that if either A is 0 and B is non-zero or vice versa, in that case it is always the answer as no. No, it will never be possible, right? And the another use case, another corner case is like if the sum of the number of times A wants to win and the number of times B wants to win is greater than the n itself, right? So over here, if we take the last example, here it is saying that the number of cards that are possible, right? A can have up to 4. So A has 4 cards with numbers 1, 2, 3, and 4. And it is saying that A must win 4 times. It means that all of the values, all of the values must have at least one value that is smaller than current value, right? To win it. So if we take example of 4, we have one value smaller than 4, that is 3. For 3 there is 2, for 2 there is 1, but for 1 there is no value smaller than this. So of course it is never possible. So anytime if sum of the number of times A wants to win and the number of times B wants to win is greater than the total n, it means it is never possible. Even if A was 3 and B was 2, it will not be possible because let's suppose for A equals to 3, we have to select top 3, and to match these top 3 we must select 3 smaller elements. So for 4 we got 3, For 3 we got 2, for 2 we got 1. But for B to win, we must have at least 2 large elements, right? So in this case we got 4, but there is no other element left for the B to win, right? Because we have already taken 3, 2, 1. So in this case we fail, right? So it is, if you try out few more examples, you'll see that if A plus B is greater than n, then the answer is no. And uh, if A plus B is greater than 0 and either A is non-zero, either A is equals to 0 or B equals to 0, then also it is not an answer. So these are the two corner cases that was there. Once we have solved these corner cases, then what we need to do is use two pointer approach. So what I did was, let's suppose this example over here. Let me yeah. So let me take this example, right? So here what I did is I am maintaining 2 pointers for each of the array. So L1 and L1 and H1 will point out the highest element from which, if A wants to win, they need to start from there, and if A wants to lose, they can start from L1. Okay. Similarly, if B wants to win, they can start from H2, and if B wants to lose, they can start from L2, right? And what L1 and L2 is going to, H1 and H2 is always going to be N, right? So let me write H1 will always be N. It always needs to start from the maximum value, and H2 is also going to be N, and L1 will be, because we want to whenever we want to select L1 only if there is A times that player A wants to win, right? So for example, over here player A wants to win at least 2 times, right? So we need to skip the largest 2 elements, and then we could select the lower elements for the player A to lose, right? So here it will be N minus A. And similarly, L2 is going to be N minus B. So which is equivalent to here it is N equals to 7 and B is 4, so it is going to be 3. So for player B, it is going to start from 3 to 1. It can take any of them for this guy to lose, right? For player B to lose. And for player 1, it is going to be N minus A, which is equals to 7 minus 2 equals to 5. So it is going to, it can start losing from 5, right? So if you see what is going to be the output for this, let me write it over here. Let's remove this. So if we start with the first, so initially we can see that let's write it all the result we got for each of the player. Okay, so initially we can see that L1 is pointing to 5, L2 is pointing to 4, 7 minus 4 equals to 3. Yeah, L2 is pointing to 3, and then uh, H1 is pointing to 7, and H2 is pointing to 7. Now if you start from A, for A to win, we basically want A to win at least 2 times, right? So we'll start with A equals to value H1 equals to 7. So for 7 it will take, and then B will take the value at L2. So it will become, yeah, let me write L1, L2, that will be better as well. L1, L2, H1, H2. Let's see. So L1 is 5, L2 is 3, H1 is 7, and H2 is 7. Now, since we want A to win, A has 7 now, and B will have whatever is at L2. So it is 3. Now we decrement this, right? So this one becomes 2, and this one becomes 6. Next we need to make it win again. So we'll take the one from H1, so it becomes 6, and this one becomes whatever is it, L2, so it is 2, right? Now A has already won twice, so we need to process for the B. B wants to win 4 times, so we'll look at B. For B to win, we'll take the largest value in H2, which is 7, and for A to lose, we want to take the value at L1, so it will become 5. Then A again wants to win, so it will become 6, and then A wants to lose, so it will become 4. We decrease these values. This one H2 will become 5 now. So now again H2 wants to win, so we'll take the value 5. Then we again take the value for A as 3. B again wants to win, so we'll take 4, and then this will become 2. So now at the end we see that we have processed for all A and B, and we need to make sure that at this point all L1 and L2 must be equal, right? Once this has been processed, we need to verify that L1 must be equals to L2. If it is not the case, if these are not equals, then it means that remaining values here L1 and L2 are equals to 1 after we have processed it, right? Means that there will be only one tie left. So as you can see, 4 wins for B, 2 wins for A, and 1 is tie. So total makes it 7. So that's why it has to equal. And once if it is equal, then while L1 is greater than 0, we'll keep adding that same value into both the result A and B. So at the end, this must be 1 and 1. So this is going to be our answer. This part. Can delete this. So this is our answer. So there are basically three conditions that we need to take care of. First is this part, that we need to validate. This is the first condition that needs to be taken care of. Once this has been validated, we start processing, and once this has been processed, we need to check if this is equal. If this is equal, then just print the answer that we have gotten so far. Otherwise, we just print it as no. So this will give us the answer. Hope you got the clarity. Thank you.